we will start the virtual lab. So in in parents meet, sir, I have been told attendance is very important. So you know very well. So definitely this time, so your marks depending upon the attendance. So I have been also told that attendance is very important. Hello, hello, am I audible? Can you hear me, dear students? Can you hear me now? Am I audible?
Yes, sir.
Hello.
Yes,
Okay.
sir.
Okay. Thank you. Screen is visible.
Yes,
Screen is there now.
yes, sir.
Okay.
Yes, sir.
Right. Okay. Welcome back to the online virtual laboratory. Uh, Good afternoon to everybody. Let's start the new experiment. Today we are planning to conduct the uh, tensile test. So here in the last class we have been discussed the IJOD and Charpy tests. These two are the impact test. Before that we uh, had conducted the Vickers harness test, Rockwell harness test, and Brinell harness test. These three tests regarding the harness, determination of the harness of the given sample. So already we have been conducted these three harness for the these three tests for the harness determination and two tests for the impact determination. So all the 5 experiments as per your syllabus. Now we will discuss the one more. The major experiment is that the tensile test. So thereafter compression is there, torsional is there. So the shear test one more is there. Now today we will discuss about the tensile test for the myosteel material, right? So you know very well about the tensile test theoretically. So let's begin the experiment. So our aim of this virtual lab, you know very well, we need to determine or we need to understand how practically uh, these experiments are going to carried out, that we can able to understand through the simulation. So by this virtual practice. Now everybody knows the what exactly the tensile test. Theoretically, in the last semester we have been discussed. Now I would like to ask a simple question here. What you mean by tensile strength of the engineering material? Please, anyone, please uh, answer my question. Please, anyone answer this question. Hmm? What exactly tensile strength of the given sample? or what is the phenomena of the tensile, how these tensile loads are acting on the sample. Principal direction of tensile force, how it would act on the material. Please, anyone? Please answer my question, please. Because you know very well about the tensile strength and tensile load, what exactly the tensile load, how it acts upon the material, what will be the direction of the tensile loads, principal direction of the tensile load. So in material science, we have been gone through theoretically, so how that tensile test works, how it's important, we have been already discussed, because this is one of the major mechanical property of engineering materials, right? Many of the ductile materials need to carry out the tensile test. I repeat, many of the ductile materials need to undergo the tensile test, because most commonly we can determine the ductile property of the material. We need to, because most of the ductile materials are come across this tensile test, because these ductile materials has a excellent deformation, so that we need to take the uh, tensile behavior of these engineering materials. So Alti, you know very well about the stress strain diagram for the mild material. Mild is one of the best example for the ductile materials, because our engineering components, many of our engineering elements or many of engineering constructions are depending upon these types of the ductile materials, right? So we have to have that practice. We should know about the mechanical behavior of these ductile materials. That's the main and almost first mechanical properties of the ductile material is tensile behavior of that particular ductile material. Once we gone through the tensile test, we need to understand their ultimate stress, their yield point, because the yield point of the each and every engineering material is very important. Once we gone through this tensile test, we can able to understand the yield strength of that particular ductile material, as well stiffness also we can able to understand through the tensile test only. We can able to understand the stiffness, yield strength, ultimate strength, right? And also we can able to understand the fracture point of that particular ductile material. That's what. So whenever we need to conduct the tensile test, best example to take the ductile material, that is best example for the ductile material for the tensile test is the mild steel material, because so this mild steel material will show all these silent features what we are now we are calling the yield, stiffness, yield, ultimate, fracture, and also we can able to discuss and we can able to understand meanwhile what will be the proportionality limit of that particular materials. All these things we can able to understand through the tensile test. Suppose if you can take a mild steel material, most of the times we are using the mild steel material only, because we can able to understand all these silent features, right? So here I will show you the tensile strength of the mild steel material. Before that, I would like to clear the definition of this tensile strength, because you are unable to define this tensile stress what exactly. So ability of the material to resist the what? What do you mean by hardness? How we can differentiate the hardness and tensile property of the engineering material? Please, simply joining the meeting or simply listening the things is not important. It's not a matter. The matter is you have to have that discussion, whether it is right or wrong. uh, I hope you understand. Hmm? What is your idea about this tensile test? Feel free to discuss with me, then only this will be useful. Otherwise simply I am explaining and simply I am moving and moving on to that simply you are listening that this is not a way. Just you can ask me or else you can answer me for my particular questions. Here this is very important. We have been discussed harness property and impact property of the engineering material. Now we are dealing the tensile property of the engineering material. Just you can compare me or how you can define the hardness property of the engineering material and tensile property of the engineering material, or else how this tensile property is different from the hardness property. What exactly happens to the hardness property when we can call it's a hard, when we can call it's a high tensile property, when we can call this a high, when we can call this material as a high impact resistance material. Unless we are not come across to this experimental this experimental conduction or experimental activities, we cannot able to say this is our, because we cannot judge with the theoretical things. Let them to undergo a practical experience that particular material, or let them to suspend under the mechanical loads. The impact is a different form of the loads, and tensile is a different form of the load, and harness also has a different form of the load. Just let that work material so suspend under such kinds of the different forms of the loads, then only we can able to give the different names. So once you look into the harness, that material, if you look into the harness property of that particular sample, right, the ability of the material to resist the indentation and penetration, which means if you can say it is a hard, that material will not undergo deformation. See, listen carefully and understand thoroughly. If you can say here we have some kinds of the engineering materials, or if you assume there will be one engineering material is there in our hand, once we can look into one, we want to spoke about, or we want to talk about that harness property of that particular material, or we are looking into the hardness property of that material. If you can say it is a hard, then that material will not undergo deformation. If you can say it is a hard, that material will not undergo deformation, that we can call it as a hardness. Okay, let it be that material is start deforming, right? The ability of the material will not undergo deformation. This is called a hardness. This is the post property, or we can call it as the physical property. Sometimes we can call it as a physical property also. Oh, material will not undergo a deformation, means that will not, or that material is resist the indentation and penetration. Then the deformation is where, if that material will not allow to deform it, then where will be the, at certain load, around about we are applying the 100 kg or 200 kg, there is no indentation, there is no penetration over the material, then nothing happens to that material. Even 200 kg, you can say it is a hard. If nothing is we at around about 200 kg, we will not get a single crack or single scratch over the material. Then how can you deform it at that point of the load? Impossible. Then the deformation will far away. Deformation means the ability of the material. Huh? What will be deformation? Ability of the material to extend or changes takes place with respect to the shape and size, even after the crack. If at around about 300 kg, if you got some indentation or penetration over the sample, that may lead to take the deformations. Deformation is a permanent changes takes place in the material, not a temporary deformations. There are two types of the deformations. That one is a elastic deformation, other one is a plastic deformations. Elastic deformation we cannot able to see with our naked eyes. That happens within the elastic limit. Plastic deformation we can able to see with our naked eyes, because that will be the permanent mark over the material, that above the elastic limit, that happens above the elastic limits. whatever the deformation takes place above the elastic limit, that we can able to see because it's a permanent mark over the material. That material will never regain its original shape and size. If it is within the elastic limit, hence it is elastic deformation. At this stage, material will regain their original shape and size. If it is in a plastic state, that will not come back to their original position. Hence, these two very important while we are conducting or while we are understanding this tensile property of the engineering material. Before that, we have to have these kinds of the knowledge. What exactly the hardness, how it's differ from the tensile, what exactly the tensile, what will be the differentiation, what will be the phenomenon, what will be the differentiation about the tensile and hardness, and what exactly the deformations and what kind of the deformations are there. See, this is the thing before we need to before calculating all these things. Ultimate tensile strength means that is what ultimate stress. Through the ultimate stress only we can able to determine the impact strength of the given material. That's not important. However, we will calculate the ultimate strength and tensile strength of that particular property. But meanwhile, we should understand how the deformations takes place in this ductile materials. That is what in the first module itself we have been discussed stress strain diagram for the ductile materials. Especially the mild steel material is the best example for the ductile material. Through that, we can able to understand the proportionality limit, elastic limit, yield stress, and ultimate stress and fracture stress. So here we have a different colors in the stress strain diagram. This is what the deformations takes place, right? The ability of the material to undergo a what permanent changes takes place in the material, that we can call it as there will be in terms of cross-sectional wise or in terms of thickness wise, there will be the permanent changes in the material. It may takes the cross-sectionally or it may takes thickness, or it may sometimes changes takes place in the volumetric or area wise. So this permanent changes we can call it as the deformations. But here we need to determine the how we can say the ability, the deformation ability of the material. How we can say the good tensile strength means how much this material will take the deformations without a fracture. Definitely, the tensile properties depending upon the deformations. Now, our aim is to, through this tensile test, now I'm coming to the aim of the tensile test. Aim of the tensile test is to know the ability of deformations when that material undergo some certain loads. Hence, that will take deformations. We need to know the ability of the deformation of that material without fracture. Before the fracture, how that material will deform. That is, we can call it as a deformation ability of that material. This is what we can say tensile strength. So just simply some people are saying it is the ability of the material to undergo a plastic deformation before the fracture is called as a tensile strength. Exactly, here we need to determine the percentage of deformations as well as the percent. That's what we can call as a percentage of elongation and percentage of reduction with respect to the particular load. How much load we are applying applying on that particular sample, and how much reduction area takes place. As a result, what will be the percentage of elongation? If it is more elongation or less elongation, at what point of load fracture takes place. Some materials deform very less, some materials will deform more, right? That is what ductility is a percent. Ductility means the percentage of deformation, how much that material is undergoing, how much material that is able to withstanding the load without the fracture. That we can call as a deformation. And tensile strength, ability of the material to undergo a plastic deformation without fracture. So that we can call it as a tensile strength. The phenomena, the principal phenomena of the load is here opposite in direction. Now we can able to how we can determine the tensile strength of the given sample. Just there will be the trick that the phenomena is to pull the both ends. The principal direction of the load is in opposite direction. Both the ends are pulled each other. When you are pulling the both the ends of the sample, definitely the cross-sectional area will be reduced, the length of the sample will be increases, right? While doing this, now we will get all these points. So once again, I will tell you this: what is the yield strength, what is the elastic limit, and no, I will not take this theory things again. You know very well about. So however, I can show you this. This is the yield area, and this is the strain hardening area. Because once that material gets strained, it becomes hard. Then that will be stand under some other some percentage of loads, because it becomes hard, because the percentage of ductility will be reduced because it gets strained. This is, we can call it as an strain hardening. Because again it becomes, because of the percentage of ductility will reduce, it becomes hard. Then that once it becomes hard, again it could withstand the amount of load. So that's what we can call it, almost that load will be almost constant, right? So due to that strain hardening. So again, after the strain hardening, the load will be increases. This will be for some period of time. So the load will be the constant. Thereafter, again load will be the decreases, because of the material is completely turned into the brittle stage, because of the percentage of ductility is gone down. Hence this material becomes brittle. When it becomes completely brittle, when it loses their percentage of ductility, definitely the fracture takes place because of brittle in nature. So this is, we can call it as a necking or neck formation, or fracture takes place. Just we can note down the ultimate and fracture point, at what point the material will completely separated. That is, we can call it as a fracture point. Ultimate material, ultimate point means before the fracture. So up to 80 or 90, the load will be the increase from 0 to 90. After the 90, load will goes down to 60, 70, 50. At 50 maybe, or 40 or 60, the fracture is takes place, right? So below this point, this is, we can, below the fracture, what will be the maximum point? That maximum point we can call as a ultimate stress. This is the fracture point, at exactly the fracture is takes place. So yield means, so below the elastic limit. So below the yield point, we have an elastic limit. So this also one kind of the deformation, that I told you, that this is also kind of the deformation, and this is also kind of the deformation. This deformation we can call it as from 0 to less than the yield point, we can get a one more point, that is the elastic limit, and this portion we can call it the proportionality limit, or else this deformation is an elastic deformation. The material here also, that material, the deformations takes place in the material, and here also material deformations takes place in the material. There are two types of the deformation. This is the elastic deformation that happens within the elastic limit. So at this stage, if you unload it, that material will regain its original shape and size. Hence, with our naked eyes, nothing happens to the material. We cannot able to understand the deformation. Also, nothing permanent mark over the material, that we cannot able to see. But once this load will crosses the elastic limit, hence it becomes yield. Once the material get yield, there will be a permanent deformation or begins to start, or there will be the permanent mark we can able to see. Or we sometimes you can call what my yield point. Yield point means which is indicated that the plastic deformation begins to start. Here the plastic deformation starts at the yield point, it will be end at fracture point. It will start from a yield point, and then it will be end at fracture point. At this portion, this is the length, we can call it as a plastic deformations, right? This end below the yield point, we can call it as elastic point through the 0 point. This length we can call it as a elastic deformation. I hope you understand, because these deformations are very important while we are conducting the tensile test. So now, so this is the thing here, they are writing the elastic deformations, the flow regions, the material hardening, the necking. These are the things very important to know. So before conducting the experiment, now I will directly go to the procedure. So how we need to conduct this experiment to study the mechanical properties of the mild steel specimen under the tensile load. Tensile load means the both the ends are hinged, both the ends are pulled each other, right? Form we can also write it the aim of this experiment uh, to determine the tensile strength of the given sample. To determine the tensile strength of the given sample. So the step one here we can able to see this is the UTM machine. This experiment is particularly conducted in UTM machines, universal testing machine. There are four major experiments we can perform in this single machine only. So right, as we can see, this is the UTM machine. So you are more I think B sections you have already this background this because you have been gone through, yes, you have gone through in your diploma, definitely I know. So once again we will go through this. Just right, step one, the measure the initial diameter of the tensile sample into the perpendicular direction using the vernier caliper. This is definitely, so you know very well about this. So before inserting to the machine, now we need to prepare these kinds of the samples. Now in our laboratory these samples are available, but only thing is that you need to know the dimensions of the samples. As per the ESM standards, we all follow the procedures, because whenever you need to conduct the tests on the particular samples or particular engineering material, then you need to follow some certain rules which are already approved by some standard institutes. Now we all together we are prepared. So the prepared sample is available in the laboratory. Just you need to take the vernier caliper and then you can check out the uh, total length of, that is what dimensions, diameter and total length. This is, we can call it as a gauge length. From this end to this end we can call it as a gauge length, right? This is the overall diameter of the sample. Before inserting into the machine, you need to determine the overall diameter and the gauge length of the sample, right? Yes. So now coming to the second step. So here the second step, this is the gauge length, right? Gauge length is around approximately 200 mm is there, right? And also you need to determine the outer diameter of the sample. Yes. Step 3, punch marks are made at the distance of the 2.5 d. So you need to make the benchmark because of the deformation is takes place after that. So you need to, after conducting, you need to take once again the gauge length of the sample so that you can mark some punches. Some people are marking like this punching machine. Some people are using the other different ways to mark using the some color codes also they are using to mark it. So you need to mark this because of we need to, after conducting also, there will be the deformation takes place in the sample due to the tensile load. Hence we need to determine, once again we need to determine the overall gauge length of the sample. That's what we need to mark it first, right? Now the first step 4 is insert the specimen into the its position and mount the extensometer on the specimen. So now then you can go for the machine and you can so insert the machines with the help of the extensometer and with the help of the motor and all this automatic. Most many of the industries or many of the institutes are now today we are having the automatic machine. Just you can use the control panel to control the machines. Earlier it was manually operated everything. Now the everything will be the automatic. Just you can use the control panel, you can control the machines, and also you can get the automatically graph so the monitor. Everything is digital now. Now coming to the step, the reading on the dials A and B extensometer as adjusted to 0. So yeah, so these things you can adjust the 0 before the conducting the experiment. So you have to check out the extensometer. This is what we can call it as a manual method, we are using the radius extensometer. Before applying the load, you need to make ensure that extensometers, A and B extensometers should be 0. In the last experiment I have been discussed with you, because we need to make ensure the 0 reading, because some instruments are already having some instrument errors, or else there any other residual stresses are present in the machine. Some environmental stresses also present in the machine. Due to the lot of reasons, there will be the errors may present in the materials. However, it is, we need to make ensure that extensometer before conducting, they should be in the 0 conditions. Then step, the experiment is conducted. Load extensometer readings are read at regular intervals of the load up to the yield point. So in my scale reading are noted in the specimen. See, this is the, you can able to see, this is what we can call it is the control panel. So the red is indicated the stop, and the green indicated that on the motor, switch on the motor. So here you can able to see your so sample. So just you can load it. The load will be gradually increases. Simultaneously, you can note down the graduated loads as well as the deformations takes place. Definitely, whenever we are applying the load, there will be the strain is developed in the material, that we can call it as a deformations takes place in the material. Strain values we can call them. So simultaneously, we can note down the load as well as the deformations. These are very, very important. So each and every load you can note down the deformations, right? So deformations and loads you can so gradually you can collect all these readings till the fracture is takes place. So once how the load is increases, definitely there will be the deformation is takes place. The cross-sectional area of the sample will be reduced. The length of the sample will be increases at certain point and certain area, or somewhere in the material, exactly middle, I think. Most commonly the middle, somewhere in the middle, the cross-sectional area will be reduced. So neck will be formed. Once the neck is formed, so we can call it as a yield. So till the yield formation, we can able to conduct the experiment. Once we got the yield, definitely there will be something noise or something, there will be there will be the drop of the load. So load is initially grows on, increases. Suddenly, once the yield is happens, load will be suddenly drops down. When it was in the increasing order, immediately it is dropped down. So it does mean that the material getting yield. Immediately note down the previous point. Previous point is now it is in 50. From 0 to 50 it increases. Suddenly 50 to 40 is dropped, or 45 the will be 45 the point the suddenly is dropped. You can note on the both the points. Previous point, that is increase in order 50. Suddenly the load will be dropped down at 45, because earlier it was increasing order. Immediately it's dropped down to 45. Immediately we can note down that at some period of time that will be a constant, that 45 will be a constant. Thereafter again the 45 again it increases to 50, 55, 60, 65, 70, 75, 80, 85, like this. That will goes on up to the ultimate, and then the fracture takes place. But once you had that experience, immediately that initially it was increasing in order, suddenly it was dropping down to 50 is a 50 is the ultimate, sorry, 50 is the upper yield point, 45 is the lower yield point, right? Note on upper yield point is very, very important. 50, note on it, because we need to determine the yield strength of that particular sample. That's what we need to note on that upper yield point. So all these activities you need to take in the step 6, right? Then take all these values, stress and strain values. You can take this stress and strain values. By helping of these values, we need to plot the graph. The graph is versus stress versus strain. Hope you understand already. You did all these things. You need to plot the graph stress versus strain. So with the help of all the recorded values, you can draw the graph. Graph will be like this, as we can discuss already. because this is what the deformation graph. This is elastic deformation, plastic deformation. As I told you that the initial load will be initially increases at a certain point. Here we can able to see up to 40 it will be increases, right? Up to 40 it will be increased. Suddenly 40 is dropped down to 35 or 38 something. Now the 38 is a lower yield point because here there will be the load will be down, says 38 or 36, right? 37 or 38 you can, or 36 you can take it is. So here this will be the lower yield point. Here we can able to say this point is the upper yield point. Upper yield point means maximum yield point of this particular sample will be the 40. Lower point will be the 36 to 38, right? And this is what the proportionality limit. Now that some period of time this 40 will be the constant. So here this area will be the constant. Thereafter you can increase or decrease the load. The load parameter will be the increase. Again now it coming to the 45. So around about 48. Here we can able to see 50. Here you can see 55. Here you can see it is a 60. 60 is the ultimate, right? 60 is the ultimate, 40 is the yield point. So 60 is the ultimate point of that particular material, because here the plastic deformation is begins, here the elastic deformation begins, because it is a 0. So here it is a point. You can understand this is the 5, this is 0, assume it is a 5, 10, 15, 20, 30 up to 40. This is, you can call it up to 35, you can call it as a elastic deformation, right? 40 is the beginning point of the plastic deformation, hence we can use to call it as a yield point, right? After the yield point also, because this is elastic deformation, this is the one life of that material. The second life of material, it is plastic deformations. After the yield also, that material will not completely break. When that material get yield, that happens only in the brittle materials. Be careful, these are the very important parameters and very important techniques and very important informations regarding the engineering materials. That's what this is. The tensile test is a very important and very informative test it is. So the ones in the ones that material got yield, so this that it does mean that that material will not completely collapse, especially in ductile materials. Only it happens in the brittle materials. Once in a brittle material the yield occurs, does mean that that material is completely collapsed. There is no deformation percentage. Only the one life, that is what, elastic deformation line. Thus such kinds of the brittle materials will not process the plastic deformations. They will withstand only up to the yield point. Once we got the yield point in that particular material, just to look into the workpiece, that workpiece is completely broken. There is no deformations. That happens only in the brittle material, but ductile materials are not like that. Once the yield got, does mean that that material will not completely break. Again, that has a capability to deform, or it, which means that has a capability to withstand against to the applied load. But brittle materials will not withstand. But these ductile materials are withstand. Even we are getting, when we are getting the yield, though they can able to resist the applied load, or though they can withstand the applied load, that we can call it as a plastic deformation. Again, the yield also, even the yield also, after the yield also they are withstanding. This is what, up to this that material will withstand against to the load, but the load value will be increases, 40, 60, 70, 80. So here we can able to identify this is the 60. 60 is the maximum. From 40, I think it is a 45, 40 it may happens the yield. Up to the 40 also, up to 60 that material will withstand. 60 is the ultimate. Ultimate it is. It's the ultimate load. After the 60, you cannot expect that material will withstand, or that will resist the applied. No, up to the 60 is an ultimate. After the 60, what happens? Again, the load will be the drop. See, the second time load will be the drop is around about 50. Thereafter 45, and finally the fracture is takes place at 45. The second time again load is dropped down, does mean that the ultimate capability of that material is gone or complete. Now this material will completely separate, or fracture is takes place at the range about 45. It will be drops after the 60. The slowly the load will be drops down and the material will the deformation or fracture is takes place at beyond the 60. If the load will be beyond the 60, immediately material fracture takes place. Suddenly the load will be dropped down at 45 degrees. So this is, we can call it as this point, we can call it as a 45 approximately. So we can call it as a fracture point. So we can take these values and these values, ultimate and yield, then we need to conduct the ultimate strength, fracture strength, like this, right? I hope you understand. So this is, I can show you, this is the graph for the brittle materials. See, there is no deformations. This is the cast iron. The cast iron is a brittle material, so there is no deformation. This is what we can call a yield. Thereafter, there will be fracture is take place. Now the ultimate and deformation. So 9 is, you need to take the again reduction in the diameters. After conducting, we need to take the again the dimensions of the sample. This is they are doing here. So the final diameter of the sample as well as the final gauge length of the sample. These two are very, very important because we need to calculate the reduction in percentage of reduction in the sample as well as the percentage of elongation. As I told you, the yield strength we need to calculate. So tensile strength means ultimate tensile strength we need to calculate. Modulus of elasticity we need to. So Young's modulus we need to calculate. Percentage of elongation we need to calculate. Percentage of reduction we need to calculate. These are the 4-5 factors are very, very important. Once you calculate all these things, your tensile test will be over. Tomorrow we will discuss the simulations, how we need to conduct this experiment by practically. So we are not able to conduct. So virtually or by simulation, we need to understand how to conduct the experiment. We will wind up the tensile test, right, tomorrow. So I hope you understand this how to conduct procedures and theory part of this tensile test, right? So now I'll wind up this class. So we will engage again tomorrow. We will engage with this class, right? Now I will take the attendance. So thank you for your patience. Okay, now you can leave the meeting.
Okay, sir.